Today. Today is the day. Okay? I've been telling you about this several times before. Some of you don't remember because you don't listen, but that's a different story. Today is the day we're going to talk about asymptotes and wholes together at the same time. Okay? You guys know what asymptotes are, right? We've been talking about that for the last couple days. All right? It's nothing, right? Okay? But it sounds a whole lot like a word that you're not allowed to use in school, right? At least the first syllable of it does, right? That's why we have rules about the word asymptotes, right? We can't unnecessarily stress the first syllable of the word. We don't abbreviate the word. And we don't walk down the hall telling each other we're going to kick you in the asymptote, okay? Because we just don't want other teachers to even question us, all right? Fair enough? So, sometimes expressions might appear equivalent, but they may not be exactly. So how can you tell for sure? So looking at y sub 1 and y sub 2, show that these two functions are equivalent by factoring and simplifying y sub 2. If I'm factoring y sub 2, I get x divided by x plus 2. Whoops, x plus 2. And that's by factoring an x out of each term in the denominator, right? Well, what does x2 equal then? Is there anything I can simplify in that fraction? I can simplify the x, right? Now wait, which x? The top one and the bottom left one, right? Not this one, but that one. Because x divided by x is itself, but the only time we can simplify things is if they're factors. Well, this x is a factor. See, it's multiplying by the rest of it. So I end up with 1 over x plus 2. Okay, 1 over x plus 2. So let's generate some tables for each of these functions. Some of you are doing a really amazing job of clearing your calculators before you put them away, and some of you are not. Please make sure you're one of the people that is doing a great job at it. Okay, so here's my calculator. I'm going to hit tab so that the equation line will come up, and then f of 1, f whatever. I'm going to put that. Control divide will give you that thing that looks like a fraction. Okay, so I'm going to have x plus 2. I'm going to hit enter so it'll graph it, and then you need to press tab again to get the equation line to come up. And this time I'm again going to make a fraction, but I want it to be x over x squared plus 2x. Okay, so now I need to look at the table, so I'm going to press Control T. And I need to look for negative 2, negative 1, 0, 1, and 2. Okay? Excuse me. So for negative 2, I get undefined and undefined. For negative 1, I get 1 and 1. Wait, should I be getting the same thing? What did we just say right here? That those two are equivalent, right? So I should be getting the same thing in my table. Right? So 0, I get 0.5 and and undefined. I thought you just told me that it should be the same. 0 is not the same, is it, on this table? But look, everything else is. So tell me, in what ways are the tables not equivalent? That x equals 0 is not equivalent. Okay? Sketch the graph of y sub 2 below. Control T. So over here, like right there, it goes... When we talked about asymptotes before, what does it mean for there to be an undefined on the table? It means there's a vertical asymptote right there, right? Now, that's not the only thing we said. We said the best way to find it is to set the denominator equal to 0, right? That gave us a vertical asymptote, okay? But some people decided that's too hard. I'm just going to look for undefines on the table. Guess what? That doesn't work anymore, okay? If life was fair, Blake, I would be rich and beautiful instead of just beautiful, okay? So, something's happening. How many vertical asymptotes does it have? How many vertical asymptotes does this graph have? 1. It has 1. How many should it have? Does that match what's in the table? There's 2 undefines in the table. It does not match. So let's talk about this one. We'll go back to that in a second and talk about it, but look right here. Find the vertical asymptotes of this function by setting the denominator equal to 0. 2x minus 6 equals 0. If I add 6 on both sides, I get 2x equals 6. Dividing both sides by 2 gets me x equals 3. So that is a what? Vertical asymptote. Okay? So coming back to my table, to my calculator, excuse me. If I hit tab, and then you hit up arrow and get rid of those functions. Because now I just want to put in this new one. Okay? I want to put in control divide to give myself a fraction. X squared minus 3x. And then denominator is 2x minus 6. Now if I go to look at my table, control T, the value for 0 is 0. The value for 1 is 0.5. The value for 2 is 1. The value for 3 is undefined. And the value for 4, when x equals 4, is 2. Does the table support the location of the vertical asymptote? What do you mean by saying yes? Undefined, right? We have undefined in the y value when x equals 3. Does the, so yes it does, right? Does the graph support it? What's the graph look like? It's just a line, right? So something like that? Is there an asymptote in that graph? No. So tell me what's strange about this graph? No asymptote. So did we do something wrong? No. Okay. Turn it over. Usually values of x that make the denominator equal 0 will create a vertical asymptote. Unless that value also makes the numerator equal 0. If this value also makes the numerator equal to 0, this creates a removable discontinuity. Removable discontinuity. Or a hole. Okay? So in this particular equation right here, the best way to know is to factor. Okay? Factor both the numerator and the denominator. Here and here. When we factor the numerator, we can take an x out of each term. And we get x times x minus 3. When we factor the denominator, we say multiplies to be negative 3 and adds to be negative 2. Well, that gives me x plus 1 and x minus 3. So what do you notice about these two terms? They are the same, and if we were simplifying, what would happen to those two terms? They would go to 1, right? They would cancel out in your terms. My terms, they would go to 1, all right? On the graph, that makes a hole, not an asymptote. When it happens in the numerator and the denominator, that's a hole. Okay? A removable discontinuity. When there's nothing that cancels out with it in the numerator, we still do that. We still set that equal to 0, but that gives us a vertical asymptote. Okay? But here's the deal. Where is the hole in this graph? At 3, right? How did they figure out that it was at 3? They set these equal to 0 also. Does that make sense? We're still setting them equal to 0. We have to decide if they're an asymptote or a hole. Okay? So if you plug in an x value and get something that looks like a number over 0, any number, 5 over 0, 12 over 0, negative 3 over 0, that's going to give you a vertical asymptote. But if you plug in an x value and get 0 over 0, what you got? Removable. A removable discontinuity. We can't abbreviate it yet. Good try though. So did I. It's okay. But looking on the table for both of these, what is it going to say? If we look for it on the table, what's it going to say in the table? It's going to say undefined, right? This is the worksheet that doesn't know what it's talking about because it actually says undefined. So no matter what, it says undefined. So to make sure, what do we have to do? We have to factor it. Okay? We have to factor it out. So here's what's going to happen. God bless you. Here's what's going to happen. I'm going to put these up on the screen, and I'm going to do number 1 for you so you can kind of see what you have to do throughout these problems, not just everything written down for you, but the thought process behind it. After we do number 1, I'm going to discuss the other worksheet with you really quick, and then I'm going to leave these other 5 for you guys to do. Okay? If somebody wants to do them on the board in class, you may. Okay? Because that'll give you some extra time, some extra help before you have to leave, if we have time to do that. Okay? So let's do number 1. You ready? I'm going to factor the numerator. Oh, I'm not going to factor the numerator yet, because I actually want to find my horizontal asymptotes first, if there's any. How do we find our horizontal asymptotes? We look to see the degrees. Those are both 2, so they are the same. When they're the same, we look at the numbers in the front.
7.
What are the numbers in the front?
7.
1. So y equals 1. Now I factor. Vertical asymptotes and the removable discontinuities will show up after I factor. Okay? So I'm going to factor the numerator, and I'm going to get x plus 2 and x plus 4. I'm going to factor the denominator and get x minus 3, x plus 2. So what do you notice about these two? They're the same. 1 in the numerator, 1 in the denominator, so that's going to tell me the removable discontinuity. Okay? So I say x plus 2 equals 0. There's a removable discontinuity, or a hole, at negative 2. So down here I'm going to write x equals negative 2. What does this x minus 3 tell me? Tells me the vertical asymptote. If I first set it equal to 0, right? So I add 3 to both sides, and I get x equals 3. That's my vertical asymptote. So what does that tell me? The x plus 4. It's extra. Okay? With all due respect, I don't really care about that. I needed to have it there because I had to factor the numerator, but it doesn't tell me anything about the asymptotes or the removable discontinuity. Okay? Any questions? All right, the other worksheet that I handed you looks like this. You should be able to fill these in, partially because that was the snow day extra credit, okay, with the exception of the last one, and we just learned how to do that one, okay? But on this one, a problem like this, this is x plus 4, x minus 4, and this is, let's see, if we were going to factor that one, we'd get x minus 4 times 3x plus 2. So what do you notice? These two are the same, so that's going to give you the RD, the removable discontinuity. Or on this worksheet, it calls it something different, right? Is that really different though? Not really, okay. So that's going to be x, let's see, x minus 4 equals 0, so x equals 4. What does this one tell me? That's going to be my vertical asymptote. So x plus 4 equals 0, so x equals negative 4, right? How do I find the horizontal asymptotes again? I look at the degrees. In this case, they're the same. Y equals 3. Okay? So I know on my graph there's a horizontal asymptote at 3. There is a vertical asymptote at negative 4. And I know I've got a hole, not me. The graph has a hole at 4. So I know the graph looks something like this. But as I'm coming here to 4, there's a hole. Got it? Any questions? Okay, so that's how this paper is going to look. I'm going to go ahead and leave this up on the board, so if any of you want to work on... Do I need to put it back? Okay, sorry?
Actually, it doesn't matter.
Okay. All right, so these are going to be up on the board. If anybody wants to get up and do any of these in a moment, you can. Other than that, get the rest of them that we did not do in class together finished for homework.